we saw how to figure out when we were in the ambiguous case and how to find the height of the triangle. So now let's actually solve for when there's one or two triangles. So the first thing we're going to do is we're going to be given three different examples. So in each three of them, first we're going to recognize that we are in the ambiguous case. So because I'm given little a, little b, and big B, the angle matches one of the sides. So I am in case 2. That is the ambiguous case, which means that first and foremost, I need to find the height. So the height is going to be the sine of the only angle that's given to me times the side of the letter that doesn't match. So when I plug that in, I get 2 sine of 70 degrees. So 2 sine of 70 degrees is going to give us approximately 1.9. So then I compare it to the letter I did not use yet, which is b equals 1. And b is less than the height. So when that happens, the triangle cannot close, so you have 0 triangles. So if I was to draw a diagram of that, this would be 70 degrees. This would be 2. This would be half of that, which would be 1. And then I would have the height coming down here to the base, which would be 1.9. And then I'm trying to close the triangle down here, but this can't swing. Like if this swinging here, it can't go. So it can't close to the bottom. It can never reach this. So this is why you have 0 triangles, not solvable. So you can't solve. 0 triangles, not solvable. Okay, obviously that's the easiest situation because you don't have to solve. All right, let's take a look at another one. So again, you have little a, little c, big A. The angle matches one of the sides. So I am in case 2, which is the ambiguous case, which means I need to find the height. So h is equal to the sine of the only angle that's given to me times the side that doesn't match. So when I plug that in, I get 2 sine of 60 degrees, which is going to give me 2 times the radical 3 over 2, which will be square root of 3, which is approximately 1.8, right before the square root of 4, which is 2. So now I compare it to the side I haven't used yet. So 3, which is A, is greater than 1.8, and A is greater than C. So when I swing at the bottom, I'm only going to touch the bottom once, so I'm going to have 1 triangle. Okay, so now we can solve. So how do we solve? So now this part is going to be new. So the first thing that you solve for is the angle of the side that's also given to you, which in this case would be angle C. And I'm going to do that by using the law of sines because I have a matching pair. So, and the pair that I have matching is A. So sine of 60 over 3 is equal to sine of big C over 2. I bring 2 over. I'm going to change the sine of 60 to radical 3 over 2. And then the only way to unglue a trig function from its angle is to inverse. So I'm going to have C is equal to sine inverse square root of 3 over 3 because the 2's cancel out. Okay, and here is my calculator ready form for angle C. Next, I'm going to find the last angle. The last angle is always the easiest because we just need to subtract from 180. So 180 minus 60 minus C. So B is 120 minus C. Now, you don't need to write C. I can literally see what it is on your paper already. You already solved for it. So it is fair game to use the letter. And we've said that previously when we were solving for right triangles, but just as a reminder. Then we're going to solve for the last thing, little b, by again using law of sines. So the sine of 60 degrees over 3 is equal to the sine of b over little b. Again, you don't need to write b. I can see that it's right there. I'm going to move this over just a little bit. I feel like it's quite in the way. So what I'm going to do is I'm going to cross multiply. So I'm going to have b sine of 60 is equal to 3 sine of b. And then I'm going to divide by sine of 60 degrees. But I can simplify that because the sine of 60 is radical 3 over 2. And instead of dividing by radical 3 over 2, I'm going to multiply by 2 over the square root of 3. Which means that b will be 6 sine of big B over the square root of 3. And you don't need to rationalize because this is calculator ready form, so this is fine. So what I'm going to do next is I'm actually going to find these values because I want to visually draw you the triangle for you to kind of visualize what's going on. So I'm going to find the sine inverse of radical 3 over 3. And I'm going to round to the nearest whole degree. So this is going to be about 35 degrees. And then what I'm going to do is find big B, which is going to be approximately 85. And then for little b, I am going to need a calculator for that. So 6 sine of 85 divided by the square root of 3 is going to give us about 3.5. So what I have is I'm given that little a is 3, little c is 2, big A is 60 degrees. And then what I found is that big C is approximately 35, big B is approximately 85, and little b is 3.5. Now, when you can find the values using a calculator, you should always make sure that the largest angle goes with the largest side and the smallest angle goes with the smallest side. That is always true. And as you can see here, the smallest side is C, the smallest angle is C. The largest side is B, the largest angle is B. So if we were to draw a visual of this triangle, here would be 60 degrees. Here would be 2. Across from it would be 3. And at the bottom, what I found is that this was 3.5, this was 85 degrees, and this was 35. And again, only one triangle exists because if you were to swing 3, it's impossible to reach the other side. It would be too much on the outside of the left side of the triangle. So only one triangle exists, and this is kind of the visual of it. Let's do one more. Okay, so let's begin by looking at what's given to us. Little c, little a, big C. The angle matches one of the sides. I am in case 2, which is the ambiguous case, so I will begin by finding the height. The height will be the sine, I need some space in the front there, of the only angle that's given to me times the letter that doesn't match. So that's going to be 8 sine of 35 degrees. And like we talked about, if you needed a calculator, I would give you the height. So the height here would be about 4.6. So now I look at the side we haven't used yet, which is C. So I have that C is greater than the height, and C is less than A, which means when I swing, it's going to hit the bottom twice. So I'm going to have 2 triangles. Okay, the really good news is that you begin exactly the same way as you did this one. So you begin doing triangle 1 identical to this, just using the values that's given to you. So let's redo what we did up for triangle 1. So we begin by using the law of sines for the angle of the side that's also given, which would be A, so angle A. So I have the sine of 35 degrees over 6 is equal to the sine of A over 8. I bring 8 over. And then I have to sine inverse. So I'm going to have A is equal to sine inverse. And I'm also going to reduce 8 over 6 because they're both even. 4 sine of 35 degrees over 3. Even though it's calculator ready, you should simplify your answers. And then what I have to do actually is add a 1 with the A because this is going to be my first triangle. So I'm going to have a second A. So this is A1. Okay, next I'm going to solve for the last angle, which is always the easiest. So B1 is 180 minus 35 minus A1, which means that B1 is 145 degrees minus A1. Done. And last, I solve for the missing side, which is little b. So the sine of 35 degrees over 6 is equal to the sine of B1 over little b1. So I'm going to cross multiply and then divide by the sine of 35 degrees. So I get B1 is equal to 6 sine of B1 over the sine of 35 degrees. Okay, so that's exactly what we did above. What's going to change now is that you're going to have a second triangle. So triangle 2. The way that you start triangle 2 is by using the first angle you solved for, which was A1. And as we talked about when I was explaining the ambiguous case, the relationship between A1 and A2, which is the first angle you solved for, is that they're supplementary. So A2 is going to be 180 degrees minus A1. Then you ignore triangle 1 and you solve for B2, big B2 and little b2, the exact same way that you did B1 and little b1. So first you have B2 is 180 degrees minus 35, but now instead you're using A2. So that's going to be that B2 is 145 degrees minus A2. And then you have the sine of 35 degrees over 6 is equal to the sine of big B2 over little b2, which means that little b2 will be 6 sine of b2 over the sine of 35. Now this is calculator ready form, but because I want you to be able to visualize this, I'm going to find the values for them so that I can draw it for you. Maybe it helps to see. So the first thing I'm going to do is find the A1, and I'm going to do this in purple to make it a little easier. And I'm going to round to the nearest whole degree, so that's going to be about 50 degrees. So that means that 145 minus 50 is going to give us 95 degrees approximately. And for the last one, I do need the calculator. So 6 sine of 95 divided by the sine of 35. And that's going to give us approximately 10.4. So that's going to be triangle 1. Then triangle 2, 180 minus 50 is about 130, which means that B2 will be about 15. And then here I need the calculator. So 6 sine of 15 divided by the sine of 35 is going to give us approximately 2.7. So if I was to write that down here, I have triangle 1, triangle 2. So in both of them, we had C is equal to 6. C is equal to 6. Big C was 35. And then we had little a was 8. So little a was 8. So what changes is the other values, right? Because these are set in stone. So for this one, A1 was 50 degrees. B1 was 95. And little b1 was 10.4. And then this one, A1 was 130. B1 was 15. And little b1 was 2.7. So now you can take a look. The largest angle is with the largest side and so on. So in triangle 1, the largest angle and side is B. But in triangle 2, the largest side and angle is A. So if we were to draw a visual of that, we would begin, oops, actually, let me do this one first. So this was 35 degrees. This was 8. This was 6. Actually, and then what we found was that the bottom side here was 10.4. This was 95. And this was 50. And in triangle 2, this was 35. This was 8. But now 6 was here. And so the bottom side here was 2.7. This angle here was 15. And this was the obtuse one at 130. So what's key to remember is that these don't change. It's just that the placement of where 6 is hitting the bottom of the triangle changes, and that changes all the other 3. So it is a lot to kind of take in, and it is the hardest case to solve for. So it's completely normal if it's, a little bit much right now. But again, the key is to first find the height, figure out how many triangles you have, and then start to solve.